Yeah, okay.
Elect
Okay. Uh, yeah, this one. Electrochemistry type. Yeah, okay. So, okay. Electrochemistry, in simple terms, yeah, is the breaking down of ionic compounds using electricity, and the ionic compounds have to be in uh, aqueous or liquid state or molten state, because if they're in a solid state, ionic compounds do not have properties that can conduct electricity. Yeah. So with it being molten or in a solution, the electrons are free flowing and therefore energy can pass through them. Yeah, kan? So you
Yeah.
see here, solid, they're just in a lattice formation, but in the molten or solution, it is like, yeah, swarming around. Okay. So the key terms in electrolytic cell. So first we have here the power supply. This can be like a battery or something. And then this one,
Okay.
the cathode and anode. These are apa? Electrodes. Electrodes attract molecules of elements. And yeah, you already know, right? And then
Yeah.
negative, the here you see this negative charge. This means that it will attract positive molecules or elements with a positive charge. So it will attract cath cations, and it's called a cathode. And the negative the positive electrode is anode, and they attract negative charged particles, which are anions. Yeah. So here you can see that positive cations gain electrons at the negative cathode. So, cations, for example, is like hydrogen. Yeah, hydrogen can be cation. Hydrogen is a cation like other metals. Most metals are cations. Yeah, or if not all. And then anions are non-metals. You just have to remember metals and non-metals. Okay, so metals have, when they're in a solution or molten form, they usually have a plus charge, meaning that they need one more electron to be balanced. That's why in a cathode they gain electrons at the cathode, yeah, here. Meanwhile, anions are the opposite and they need to give out one. Actually, wait, no, I'm stupid. It's the opposite. It's completely backwards. Metals need to give away their electrons, while non-metals need to gain electrons. Okay, so down here, basic setup of electrolytic cell. Yeah, this one. After that, change transfer. Yeah, okay. So this one, during electrolysis, the current needs to flow around the circuit. Yeah, this one, you see?
Yeah.
Yeah. And then the power supply provides the cathode and cathode with a supply of electrons. So the battery here can flows in this direction from right to left, and the
Yeah.
cathode left. That means that the battery is supplying the cathode with electrons to give the metals charges. This one, any plus ions. They're attracted to the cathode. And then this one, positive ions, which are cations like the metal, sodium, and the electrolyte move towards the cathode where they gain electrons. Yeah, this is the electrolytic solution or the electrolyte. Yeah, electrolyte. Electrolyte is the molten
The
or aqueous state of the ionic compound, and where ionic free flowing electrons are found, and they just get attracted to here. Sodium gets attracted to the cathode, and then chlorine gets attracted to the anode. Just remember C and C, cation with cathode, anode with anion.
Okay.
And then, yeah, this one, the direction of movement of electrons. anions in the electrolysis of NaCl. This is what happens in NaCl. Yeah. Tapi this is only concentrated NaCl. No, wait, no. Yeah, this is NaCl, yeah.
Berarti if nggak concentrated beda lah.
F concentrated itu biasanya ya NaCl itu, wait, I'm gonna draw a whiteboard aja. Wait, yeah. Usually if it's not concentrated, yeah, the sodium gets attracted, it doesn't get attracted to anything. Like it just stays in the electrolyte, like this one, yeah. Cath
Oke.
plus this, wait,
N minus.
plus minus, yeah. Okay, so there is always hydrogen, hydroxide, and a plus sodium, and then Cl. Okay, so ini there's rules for this ya. Later I'll explain. Pokoknya Cl will be found in this, the anion, and then
Ya.
it's not concentrated ya. If it's not concentrated, hydrogen will be formed here. Tapi I'll explain that later. Hydrogen will be
Okay.
formed here, and then in the electrolyte, it will just be, electrolyte will find NaOH, sodium hydroxide. Sodium hydroxide will be in the electrolyte. Yeah. Tapi that's only aqueous. Aqueous. This is aqueous, ya kan? There's
Yeah.
no molten NaCl. Okay. So here to predict the products made at the electrode, first identify the ions. The positive ion will migrate to the cathode, and the negative ion will migrate to the anode. Yeah, C and C, cation cathode, anode and anion. Therefore, the cathode product will always be the metal or hydrogen, and the product formed at the anode will always be a non-metal. Yeah, this one. Yeah. So the positive lead ions are getting attracted to the cathode, which is the negative electrode. Yeah, and then the opposite here, bromide ions attracted to the positive electrode, which is the anode. Yeah, okay. This one, aqueous sodium chloride. Yeah, brine is a concentrated solution of aqueous sodium chloride. So therefore we can say that this is brine, yeah, because we can find sodium in the cathode.
Okay. So if it's not sodium chloride, nggak bisa diomong. We cannot say it's brine.
Yeah, I guess brine is only for aqueous concentrated aqueous.
Oh, okay.
Okay. It can be electrolyzed using inert electrodes. Inert meaning that the electrodes are not making contact with anything. Like usually if you have like carbon electrodes like this one, carbon electrodes. Usually carbon can, if there is oxygen, yeah, carbon dioxide will be formed at the cathode. So carbon dioxide gas will be escaping and stuff. That is not inert. Inert electrodes do not react with anything made from platinum or carbon or graphite. Yeah. When electrolyzed, it produces bubbles of gas at both electrodes. Chlorine and hydrogen are produced. Yeah, see, chlorine and hydrogen are produced, leaving behind sodium hydroxide. Yang before the show in the whiteboard, this one.
Yeah.
Yeah. Okay, and then yeah, there's the industrial uses like chlorine to make bleach, hydrogen to make margarine, sodium hydroxide to make soap and detergent. Okay, this one, products of the negative electrode here. The hydrogen ions are discharged at the cathode as they are less reactive than sodium ions. I'll bring up the reactivity actually. Wait, is it here? Oh yeah, here. I'll show you later. Okay. As they are less reactive than sodium ions. And the hydrogen ions gain electrons to form hydrogen gas. And then hydrogen gas escapes, ya kan? And then positive
Yeah.
electrode at the anode the chlorine ions are discharged at the anode, they lose electrons, form chlorine gas, as, and then the chlorine gas escapes. That's why you can smell chlorine last time in Mr. Rat's experiment.
Yeah, it smells like fucking
Swimming.
pool water.
Yeah, that's why. Okay. The Na and OH yang tadi, this one, the electrolyte, they're stuck in the electrolyte, they remain behind and form sodium hydroxide
Yeah.
in electrolyte. Yeah, okay. Electrolysis of aqueous solution. Aqueous solutions will always have H2O. Pastilah ya, because you add water into it.
Because it's aqueous.
Yeah, okay. Yeah. And electrolysis of aqueous solutions, the water molecules separate ya kan. The water molecules separate, producing hydrogen plus positive ions and hydroxide ions negative.
Yeah.
Okay, these ions are also involved in the process and their chemistry must be considered. Yeah, like this one, hydrogen, and then there's sodium hydroxide. Okay, we have now an electrolyte that contains ions from the compound NaCl and ions from the water H2O or H plus and hydroxide, hydrogen and hydroxide, which ions get discharged and at which electrodes depend on the relative reactivity or reactivity series of the elements involved. Yeah, like before, yeah, kan? This one. As they are less reactive. If it's more reactive, that means sodium ions are, yeah. Okay. Positive electrode, negatively charged hydroxide ions and non-metals are attracted to the positive electrode. But if halide ions are present, like Cl, Br, or chlorine, bromine, or iodine, the halide ions will always be discharged or found in the anode. For example, like if there is bromine gas instead of chlorine, bromine will always
Yeah.
be the positive electrode because it's a halide ion. Wait,
Okay.
maybe I'll table anymore. Let me show you. Yeah, this one. This halide ions, chlorine, bromine, iodine. This one. In
Yeah.
this,
Sing biru though, the blue one.
no, in this row, this one. Chlorine, bromine, iodine. This row, halogens.
Oh, the 9, the 17.
9, 17, 35, 53. Halogens are halide, by the way. Halide is just like a plural. Not really plural, but yeah. Okay. If halide ions are present, then the halide ion is always discharged at the anode, losing electron and forms a halogen. These three most common found in experiments. If no halide ions are present, that means hydroxide is discharged at the anode. Okay, and loses electrons and forms oxygen gas. Okay, if both cases the other negative ion remains in the solution, the concentration of the solution also affects with, yeah, this one. Concentration also affects which ion is discharged. If concentrated halide solution is being electrolyzed, the halogen forms at the anode. But if it's dilute halide solution, that means oxygen is being formed. Yeah. Okay, for example, concentrated solution of barium chloride. The chlorine ions are discharged more readily than the hydroxide ions. So chlorine gas is produced at the anode, concentrated solution. And if the solution is dilute, only the hydroxide ion is discharged, so oxygen will be formed. Dilute. Okay. Negative electrode. Positively charged hydrogen and hydrogen ions and metal ions are attracted to the negative electrode, but only one can gain electrons from the electrode. Either hydrogen gas will be produced or the metal is produced. So harus ada sodium or hydrogen. If the metals above hydrogen in the reactivity series, this one, yeah. You see how sodium is higher than the hydrogen here in the reactivity series?
Yeah.
Here. Then hydrogen will be produced and bubbling will be seen at the cathode. That means hydrogen gas is already escaping. But if we have like copper or copper, silver, or gold, yeah, these three, if we have them
Yeah.
solution or molten, if you have them in the solution, they will be found at the cathode instead of hydrogen. Just look at this table, yeah. If the metals above hydrogen, pokoknya hydrogen
It's
will
more
be,
reactive.
yeah, more reactive than hydrogen. Hydrogen will be produced at the cathode no matter what, unless if it's unless the this is because the ions of the more reactive metal remain in the solution, causing the ion of the least reactive metal to be discharged. Yeah, least reactive metal to be discharged. Okay, therefore at the cathode, hydrogen gas will be produced unless the positive ions from the ionic compound are less reactive than hydrogen, in which case the metals produced, like copper, silver, or gold. Okay, this one. Example, electrolysis of aqueous copper sulfate. Aqueous copper sulfate contains the ions like copper, copper 2 plus ions, sulfate ions, hydrogen ions, and hydroxide ions. This using graphite electrodes, yeah.
Yeah.
Power supply battery 12V DC. This the
For
apparatus.
electroplating, yeah, Rob.
Electroplating masih later. Okay. The product at the cathode will be will either be copper or hydrogen because they have a plus charge, ya kan? Cc
Yeah.
cathode. And they will be both attracted to the cathode, but the less reactive ion will be discharged. So, Chai, which one will be discharged? Hydrogen or copper?
Hydrogen.
Enggak lah ya, Chai. Copper. Because kan copper is less reactive. Anything down
Oh,
here will be formed at the cathode if it's below hydrogen. If it's above, hydrogen will be discharged. In this case, copper is less reactive than hydrogen in the reactivity series, and then therefore copper ions are discharged at the cathode, gaining electrons and are reduced to form copper metal. The equation for the reaction is this one: Cu2 plus 2E. Yeah, and then forming copper metal. The product at the anode, this one, sulfate and hydroxide. They're both attracted to the anode, so either one of them will be the products at the anode. Hydroxide loses electrons more readily than sulfate. Therefore, hydroxide loses electrons and oxidizes to form oxygen gas. The half equation for the reaction is this one. For hydroxide, this balanced, by the way, has to be balanced. That's why there's four. For hydroxide
oh,
forming oxygen gas plus 2H2O plus 4 electrons. Yeah, this is the discharge. This is the products formed. Okay, using copper electrodes. Yeah. Okay. Yes, how much I think. This is the apparatus. This how the experiment should be.
okay.
Observations of the anode and cathode. The cathode increases in mass while the anode decreases. And this occurs as copper atoms are oxidized at the anode, forming ions, while copper ions are reduced at the cathode, forming copper atoms. That means in the in the anode here, you know how in the anode oxygen is attracted, ya kan? Hydroxide is attracted to the anode. And since
Yeah.
this is a copper electrode, that means hydrogen and oxygen and copper is forming in the anode. That means
Yeah.
the copper atoms are oxidized, gaining oxygen and forming copper oxide. Yeah. And form ions while copper ions are reduced at the cathode. At the cathode, they're reduced, forming copper atoms. Because copper kan, wait, because copper kan itu positive ya kan?
Yeah. Oh,
Wait, I need to check something.
okay.
Bentar, 10 menit. Oke, Chay, I'm back. Udah, Chay?
Okay.
Okay. So, yeah, copper atoms are formed at the cathode because copper atoms are copper ions have a positive charge. And the gain in mass by the negative electrode is the same as the loss in mass by the positive electrode. Therefore, the copper deposited on the negative electrode cathode on the cathode must be the same copper ions that are lost from the anode. That implies that concentration of copper ions in the solution remain constant. That means the concentration is constant. It's not like dilute or concentrated, it's just the same.
Okay.
Yeah, this one. There's like the common solutions that Mr. Rod uses.
It's like the ones that show up the most in Mr. Rod's test
Yeah,
and exam.
yeah, the most common ones. Concentrated, dilute, yeah.
Okay.
Okay. So in concentrated sodium chloride, chlorine gas is released from the anode, and the product of the cathode is hydrogen, both of them hydrogen. And then anode, this one, the dilute is oxygen because it's dilute. And then this one, concentrated aqueous copper solution, copper sulfate solution. In the anode is oxygen, and the cathode, wait, copper is lower than the hydrogen in the reactive tissue, so copper is discharged. Yeah, so copper is found, huh? Okay, I'm back. And then dilute sulfuric acid, H2SO4, very common. Oxygen gas is released at the anode, H2O more readily. So yeah, so H2O is formed. Oxygen. And then in the cathode, hydrogen gas is released. Okay, ionic half equations. This one very important. Yeah, just skip all these. Unless you want to. Actually, no need lah. Just remember this one. Anode Negatively charged ions lose. Anode lose, cathode gain.
Okay.
Anode oxidized, cathode reduced. Wait. There's like itu juga sih. There's
Apa?
some
Why?
Mr. Rod said something about this. Wait. Apa? Um, Manila. Okay. Here, lead bromide. Bromide is formed in the anode. Therefore, the ionic half equation is 2Br negative 2Br minus, forming bromine gas and giving away getting 2 electrons. This one. In cathode, Pb2 plus 2 plus 2, yeah, okay. I'll let you digest this for a while.
Okay. Reduce itu gain ya, Rob.
Reduce is gain, yeah. Oxidized is lose.
Is it like the opposite?
Yeah. I don't know how to use Google. I'm gonna get myself. Udah.
Done.
Okay. Okay, electroplating, yeah. This one yang you asked before. So the power pack is like almost the same apparatus, tapi in one of the sides you put like instead of electrodes you put itu the object you want to like electroplate or the metal that you're going to electroplate with. Here, the anode, which is the positive one, is made from the pure metal you want to coat with your object with. And the cathode, this one, will be the object you want to electroplate. That means the object you want to coat. Wait, no, wait, I'm lagging. The cathode is where, wait, I'm lagging again. The anode is made from the pure metal you want to coat your object with. Okay, yeah, the cathode is like your necklace, jewelry.
Okay.
Yeah,
Is it a long process, Rob, to electroplate?
enggak sih. In Mr. Rat's experiment loh, it's like pretty fast. It took about like five
But
minutes.
it's not like fully nggak sih?
No, it
Fully
was
eclipse.
like 5 minutes. The copper fully covered the coin. Tapi I don't know with
Oh.
bigger objects sih. Maybe like
Does it depend on the metal?
I don't know sih. Maybe I'll search that later. Okay, putting a strip of iron metal with tin. This one, the strip metal and the anode, the
Yeah.
pure metal and the anode, and then the object you want to electroplate and the cathode. This one.
Okay.
Okay. Piece of iron being electroplated with tin. Yeah. So iron on the surface will have the properties of that like look like tin, you know. So at the anode, tin loses electrons to form tin ions in the solution. So tin will like break down. Oh god, yeah. Tin will like break down. Like wait, let me show this. Like
Yeah, like it'll like break off to go to the itu nggak sih? To the
yeah,
completed.
the tin will erode, and then some parts of the tin will be cut off because kan
Yeah, it's like just going to another place. Right?
cut off, cut off, and this one will be coated.
Yeah.
Yeah.
Last time on Mr. Rots itu. Rob, you're muted, Rob.
Apa?
Oh, you were muted before. Rob.
Yeah. I had to mute for a while.
Look, after this, we make a new meeting, Rob.
Yeah, yeah. I'll save the recording. I think it's 30 minutes already. Okay. Anode, yeah, this is losing electrons. The tin ions gain electrons to form tin atoms. which is on the iron. Yeah, that means the tin is already coating the iron. Okay, hydrogen fuel cells. Yeah, I don't think Mr. Rod explained that much of hydrogen fuel cells. You have Rod talk gak sih?
Yeah, we did. Yang like TED Talk, and we have to explain like why is it expensive and why we're not using it in a wide range.
I can explain to you my Rod talk just to make it.
What the hell?
Okay, so
But
yeah, my Rod talks about ini fuel. Fuel can cause to global warming, CO2, yeah, that's from energy, yeah, can energy comes from fuel, all of these, all of these, all of these. Yeah, after
okay,
that, if you use hydrogen fuel cell, you will
produce water nggak sih?
mention renewable, yeah, safe. This one is like criteria to have perfect cell, yeah, a perfect fuel source. All of these, tapi none of them,
Expensive, bro.
yeah, tapi hydrogen is just better. Tapi how do we make it like less expensive and more efficient using nanoparticles? Like yeah, in chemical reactions kan we learn uh catalyst. This is like a catalyst. Catalyst
Yeah,
can enhance the
make
speed.
the reaction faster nggak sih?
Yeah, this is basically it. So platinum nanoparticle has catalytic activity because of its small size and catalytic stability. Yeah, this hydrogen fuel cell.
Stability.
And the nanoparticle will be placed in here.
You're lagging, Rup.
Oh, really? Hello? Still lagging?
Yeah, hello.
Okay. So the nanoparticle, the platinum nanoparticle is used in the hydrogen generator to increase the efficiency and lower the cost. Because kan having a catalyst will reduce the amount of energy needed to have this happen. Yeah, so here you put the nanoparticle in and then it will start forming temporary bonds and then until they find each other and then boom, hydrogen oxygen created. Yeah, so put water in. After that, the water will split into oxygen and hydrogen. Hydrogen will be stored and then burning of hydrogen fuel. And burning hydrogen fuel only emits steam or H2O in gas form. Yeah.
Yeah, but it's expensive, eh?
Yeah, tapi nanoparticles or catalysts will reduce the cost.
Yeah.
Okay. Back here, the only chemical product is made of what is made as water. So water would be like formed, So the fuel goes in, and the air also goes in. After that, gets displaced here, oxygen, hydrogen, and forming H2O. They go in the middle. After that, they form H2O. Excess fuel and water goes out, and unused gases go out also. Okay, disadvantages and advantages. Hydrogen oxygen fuel cells are becoming more common in the automotive industry to replace petrol and diesel engines. Yeah, to save the world, yeah. And they do not produce any pollution. The advantages, no pollution, and the only waste product is water, where petrol engines produce carbon dioxide and oxides of nitrogen that can harm the environment and produce greenhouse gases. And they release more energy per kilogram than petrol or diesel. That means that hydrogen produces more energy than petrol or diesel per kilogram.
Yeah.
And there's no power is lost in transmission as there are no moving parts. Unlike an internal combustion engine. Combustion engine kan the engine has to move like ya kan. You ever see, right?
Rup, and first aja, Rup.
Ya udah. I make a new one ya.
Ya, oke. Make it faster aja. Like,
Record. Okay, I'm recording. Okay. I
make it
forgot.
faster because we skip.
Oh. Okay, so you already know exothermic release heat to the surroundings, endothermic.
Yeah, and take in heat.
Yeah, okay. This the thingy. Exothermic, the reactants have more energy, endothermic, the reactants have less. And
Yeah,
okay. Enthalpy change. Enthalpy change is the difference in energy between the two.
yeah,
And
the change, yeah.
the difference of energy is this one, the red arrow.
The
And
delta H, huh?
the delta H. Activation energy is how much energy it requires to break or make new bonds, which is this one, the green arrow.
Okay,
That's how much energy it requires, yeah. Okay.
yeah,
Exothermic reactions. Hey, that was exothermic reaction, yeah. More energy in the
yeah,
reaction.
yeah.
Yeah. Okay. Go down here, endothermic. The activation energy is the entire thing. And
Yeah,
the delta H or the enthalpy change, difference in energy, is this red arrow here. And it's positive. For exothermic, it's negative. Okay,
yeah.
bond breaking, bond forming. Yeah, this one. Yeah. Okay. So H2 plus Cl2 to form 2HCl. How do you calculate the enthalpy change?
So
First,
you look at the graph. I got the graph, the
436
the
plus 2
thing.
for 3. You get 679. And you calculate for
Yeah,
the other side 2HCl. That means 432 times 2. 864.
yeah.
You minus the left side with the right side. 679 minus 864, giving a negative enthalpy change. Negative enthalpy change
So,
as exothermic.
okay.
Yeah, this one,
Before, like the one before.
hydrogen bromide to form hydrogen and bromine gas. Calculate the left side will be 366 times 2 because there's 2 hydrogen bromide. And then the energy out will be H2 and Br2, which is 436 plus 193, which is 629. So we minus the left side with the right side, 732 minus 629, getting 100, positive 103 kilojoules per mole, which is a positive enthalpy change, meaning that the reaction is endothermic. Yeah. Okay.
Yeah.
So yeah, that's basically it.
Okay. My turn.
Yeah.
Um,
It's your turn. Yeah, sure. Let's go.
did you record that time?
Yeah, yeah, I recorded the time.
Host disabled participant screen
I
sharing.
made you host. I made you host. I made you host.
You see my screen?
Wait, yeah, I can see your screen.
Okay, so first you have chapter 7, which is about chemical reactions. A reaction is a physical change that does not result in the formation of a new substance. It simply alters the state of the substance involved. For
Oh,
example, when ice melts to form water, it is a physical change
okay,
because the water has not changed its chemical formula.
okay, very nice.
Wait, wait, wait. How do I exit? I don't think. Hold up.
Uh, just click the backwards arrow, the undo, redo,
Okay.
undo.
Also, this one. Wait. Why can't I go down? Also, I cannot use my key. Okay, so this is like an example of a physical change. Like for example, this one. I don't know what this is. I think this is like
Tofu.
tofu.
Yeah, tofu, I
Yeah,
think.
it's like so from the blocky tofu, they boil it and then have the physical change.
Uh,
Uh,
wait, that's cheese.
oh yeah, that's cheese.
What? It looks so like tofu, bro.
Yeah. Wait. I need to go to this part, but I cannot access it. Basically this one like you can look from here. It's like so the one you explained before, activation energy is an energy that is needed to make to form or to what is that destroy the
Yeah.
okay. Wait. So this is also a chemical reaction. For example, limestone calcium carbonate CaCO3 is a substance which can be used to neutralize acidity of soil. Powered
Oh,
limestone is used to neutralize the acidity faster than if limestones are used, like Mr. Rod last time show us gitu loh.
yeah.
So this one has a faster chemical reaction than this one.
Mm-hmm.
And we measure it at regular intervals, the total loss of mass, and calculate for each reading of the balance.
Mm-hmm. Oh,
But in some industries, the large surface area of a fine powder can be very dangerous and can be a problem. For example, there is a risk of explosions in flour mills and mines where the large surface area of the flour or coal dust can and has many times resulted in explosion through a reaction with oxygen gas
uh-huh.
in the air with when a spark has been created by machinery or the workforce.
Oh.
Yes, that is one. Temperature. Okay, so what do you think temperature is?
Yeah, temperature, heat.
Yeah, but temperature, yeah, temperature is heat. The temperature doesn't only include heat. It's like your refrigerator. Like your refrigerator contains a temperature to make your food last longer.
Yeah.
This the rate of decay is lower at lower temperatures because this is a general feature of the majority of chemical processes. The reaction between sodium thiosulfide and hydrochloric acid can be used to study the effect. Okay, so a catalyst, as you said, a catalyst is a chemical that you use to make the rate of reaction faster. So over 90% of the industrial processes use a catalyst to make the chemical process go faster.
Uh-huh.
Example of catalysts are like mostly iron and mostly metals like iron.
Oh, yeah, okay.
Okay, so this is a graph of the increase rate of a catalyst.
Uh-huh.
So you can see that with a catalyst, it's faster to make the products than without the catalyst.
Yeah.
Wait, let me annotate it. So you see this one, the one that's written without catalyst.
Yeah.
The one written without catalyst is like the original one that you don't use catalyst. So it's like more up here because it will take longer.
Oh.
Okay. Okay, so some reactions of chemicals can be reversed. Most chemical reactions simply change reactants into products. For example, carbon reacts with oxygen to produce carbon dioxide. But
Oh.
the carbon dioxide produced does not only change back to give carbon and oxygen again. However, some chemical reactions are reversible. These are reactions in which reactions form products which can then react further to produce more reactants, which reverse the process and produce the original reactants.
So it's just like changing, yeah. Like,
Yeah, it's like you reverse it.
oh, yeah, okay.
So these are the exam style questions that you can use to study for Mr. Roth's test. Usually Mr. Roth use this for the like task if you fail your test, I think.
Yeah. Or
Okay,
the
that
physics or math.
yeah, yeah.
Eh,
Okay.
I don't think that's 1 hour yet. Wait.
Already, Rob, I think.
Oh,
Mestinya udah.
enggak, seharusnya enggak. I think that was only like
For
20.
how much do you think?
I think it's like 20 or 15 minutes. Soalnya kan I forgot to record.
No, the 1 hour is like for itu gak sih? 1 hour is for like combined gak sih?
Yeah, combined though. Yeah, the previous one was only 35 minutes.
Ya,
Tadi.
coba try checking. Bro.
I checked lah. Masa we end the meeting? No, we do ini aja. I'm gonna share screen ini.
Dua baru. What the hell?
Nih.
Udah sejam mesti nih, Rob. Even if you
Enggak.
nggak, never mind. I don't think so.
Ya
But never
belum,
mind.
belum. Anjing.
What the fuck?
Ya,
What is that? Alibaba, Rob? What the hell?
ya I also don't know how to get rid of this, bro.
Yeah, it's an ad call. It's fine.
So annoying, man. Jelas. Aduh, you aja open this ini aja, coy.
Later keluar itunya, bro. Okay, send to me in WhatsApp.
We do quiz aja. Quiz is.
Oh iya, no, do itu loh. Don't do quizzes. What's that called? Booklet or something. I forgot.
Look at, you want look at,
Yeah, that's more fun, gak sih?
look at.
Just find about like one about the chemical reactions and one about like
The chemical react, chemical reactions. Look at flashcards or what?
what?
Or do we literally play?
Play lah, gas.
Tapi nggak ada. Can't find, coy. Quizlet.
Really? Doesn't booklet have everything?
Nggak ada. I can't find blockets ini. And I can't find anything that has blockets itu.
Okay, I'll make it right.
Ya, you cari aja. Ada kalau nggak.
Bro, I have to log in. What the fuck?
Hai.
But like chemical reactions, yeah, okay.
Yeah. Where's Alibaba taking over my PC, bro?
Because it's Chinese, bro. Look, Rob, what did you do with Mr. Roth before? Lab.
In the lab.
Yeah.
Wait, I'm recording, Sai. I cannot tell you.
Okay, Rob.
Pokoknya we just did some experiments.
Did you do the religion already?
Ya udah. Mana Cai? Where
You
is
wanna
your
do what?
where is your thingamajiggy? Where's the thing?
Uh, You wanna play Crypto Hack or Golden Quest? Gold Quest.
Crypto hack aja.
I host, okay.
Yeah.
Loh, Rob, rally you live or recording?
Ah,
Religion you do it live or recording?
loh, we have to record kok.
No, you can do it like you can do it live, bro. Are you
In
dumb?
class.
Iya, Dam.
I don't know. I was just following itu. I was just following it. Can you start?
Live, males, Bang. Here, I send it to you on WhatsApp.
I share screen dah.
Ya, terserah. It's only like 20 questions, so but it's like 7 minutes. So it's like repeated.
Join, Cai. Kita buy
Okay,
one.
I'll come here.
Jadi ikan. How do we get legendary ya?
Oh no.
I want legendary, bro.
But
Can
if
you
you
start?
play with 2 people though, it's like so little, the crypto, bro. It's like so little.
Gak apa-apa, Cai. Don't be scared.
Shit, fuck up, bro.
Heh.
Start ya.
Ya, gaskan.
I skip this ya. You know how to play, right?
Ya, I tahu lah.
Don't tell me that you never played this, bro.
Oh, pernah lah. Oh, I always lose, bro.
What the hell, bro? That's like that's a bad thing to say.
Bro, aduh kalah terus, man. Because like I
Bro,
can.
you know, Cat lo, so sneaky, man. You know, I was like on top. I was like number one, right? For Chinese, we were playing Blue Cloud, and he waited until the last second to steal all my money, bro. Motherfucker.
Wow. Dude, I'll never get to steal money from people.
I think you're just bad.
So unlucky, bro. Just so unlucky. I can never get a triple hack, a triple, itu.
Bro, I got 10 crypto. Let's go.
Triple crypto. I already have nothing.
Yeah, I always last
I
time I was Chinese, I also got that.
double crypto. I have nothing, bro.
Chill out, bro. Chill out. I have 10 Bitcoin.
Coefficient apa ya? I lupa.
Apaan so, bro?
Cil, I lupa goblok. Wait, no, I'm actually selling, bro. What am I doing? Wait to see if chemicals change.
Go down. Oh, I got triple crypto. 30 Bitcoin.
Nothing. What? Oh, I don't understand. What am I doing wrong, bro? Oh, running out of time.
I
Yay.
think you're picking the wrong one, damn.
Itu, so that means I need two. Two,
Let's
three.
go. I have 90 crypto, bro. Get
Hmm.
wrecked, bro. Form of chemical reaction
Oh,
is.
I can hack you.
Bro, doesn't know my password. Chill out.
This world, dude.
Nah, it's not. What the hell? Are
Ah,
you high?
apa sih this one? Ah, wait, what the? Oh, free question. Tony Crypto, let's go. I'm so dumb. Wait, I'm so
Let's go. I
dumb.
get to hack Ruby.
No way, I'm so dumb. I'm so dumb. I'm so dumb. Small number.
Let's check. I think this is your password, bro.
What?
Oh, never mind. What the fuck?
Behind? Huh? It's a subscription. 10, wow. Beautiful. 50.
Beautiful. Another hack.
Freezing water.
How many Bitcoin do you have, bro?
30.
Oh my god, what the hell? Why are
120,
you
I
so
mean.
poor?
120, 120.
Oh, let's go. I'm stealing. Get wrecked.
Oh, I can hack you, bro. Watch out. Yeah. I stole 76.
It's fine,
That's
bro.
breaking in half. Example of.
Bro, my battery gonna die. I need to do religion.
Talking in
What is this random question? Who is the best
your
teacher,
hair.
Mr. V? What the hell?
What is an exothermic? It is released. Double. Oh, I'm winning.
Hack, bro. Let's go. How much Bitcoin do you have?
632.
Huh? How much?
662 now.
Damn. How do you know you're winning? Can you see the? Can you see
I
the
don't know.
thing?
I'm probably winning. Reasonable.
Don't be so confident, bro. I'm hacking you now. Let's go. I saw 200.
Alah, there's barely anything to me. Huh.
Bro, I got 10 crypto. What the hell? I got nothing.
Lol.
So I got 30 crypto. I get to hack you again. Let's go.
Double. Subscript. Subscript is a small number in front of a behind. Huh? Salah. This teacher is wrong.
Bro, chill out. Don't blame the teacher. Blame yourself.
No, this teacher is wrong. Mister, you see this teacher? Look, Mr. V is wrong. I'm correct.
Oh, I just stole 600 from you.
I also stole money from you, Jack. I don't actually think
Oh,
that.
triple crypto. I'm winning, I think.
Go ahead. Double. The bonds of reactants are broken.
Let's go 30 crypto.
Triple! Oh my.
Double crypto. Oh my days, 10 crypto. What the hell? Let's go. I get to hack Ruby again.
Dude, what?
What do you mean?
Why do you keep hacking me, bro?
Bro, because I'm him. Oh my god, why do you have so much money? I just saw
No,
6K.
wait, what? It's 9. Oh, yes, eh? I'm so smart. How do you know I have so much money?
So I get to hack Ruby again, bro. Wait, I have to check. My mom is texting me again. Never mind. Bro, I just stole 7K from you.
You stole 5K from me, bro.
For real? You? Oh, I got double crypto, damn.
Oh no. Oh, please, bro. Double.
How much money do you have?
41K.
I'm winning, dumbass.
Really?
Yeah, I have 49.
Ah!
Oh, double crypto. I have 98, bro. Let's go. I have another chance to hack you. Let's go. I'm so rich.
Dude, what? Why do you keep hacking me?
Because
What?
I'm him. I was in this game, bro. I'm like so lucky, bro. I just stole 58K from you.
So 38K from me, bro.
For real. I hate you.
Oh, hacking you again, back to back. Are you serious?
Let's go. I got 50 crypto.
This is free, bro.
Let's go. I got 30 crypto. Let's go. I got 20 crypto. What the hell?
Nothing. Beautiful. Double. Beautiful.
How much money do you have?
500K.
So where? What the
1.4
hell?
mil.
I'm stealing money from you, kids. Shut the fuck up. I just stole 148,000 from you.
That's nothing to me, bro.
Bro, chill out.
How long is this, bro?
Double. I got nothing, dumb. What the hell?
How long is this? Chai.
7 minutes. Chill out.
Chai, the timer's about to run out, Chai.
Really? I don't care.
I'm still in the window.
I'm hacking you again.
Dude.
Yo, I just stole like 600K from you, bro.
Huh? I don't even have that much, bro. Damn. What am I doing? I'm selling, bro. Oh
How
my.
much do you have, bro? How much money do you have?
3 mil.
Oh, damn. What the hell? That's more than half of me, bro.
Yeah.
Bro, I'm stealing your money again, bro. Shut the fuck up.
I'm hacking you, bro. Is that
Bro,
what's
I'm
up?
hacking you too, dumb. I got 1.1 from you, bro. Chill out.
Oh yeah. I got. Okay, bro.
Bro, I'm poor, bro. Chill out.
You're getting away with this, bro.
Double crypto. Let's go.
I'm hacking you again, bro. Yes.
Let's go. I get to hack you again. What the hell? You don't have the intuition.
Oh, no, damn.
There's a log. I think this works.
Huh?
We could find three log.
Okay.
Huh?
Okay.
Fucking dumb, bro. Why am I so dumb?
Oh, what am I doing? Oh
How
wait,
much money do you have?
I have 11.5 now.
Bro, I only have 5. What the fuck?
Oh, why am I this better? Chemical changes when a substance is made.
Bro,
Is
it's not him. What the hell? I got nothing. I got 10 crypto. Bro, why am I so bad? Why am I so unlucky?
Or I'm just better.
Bro, I keep getting nothing. Bro, what the hell?
Nothing.
How much money do you have?
14 mil. 28 mil, I mean.
Damn, I have 5 mil, bro. What the fuck?
Oh, I mean, 85 mil, sorry.
What the hell? Why am I so poor?
Oh, Chai is gonna end, Chai. Okay, guys, that'll wrap up this thingamajig. Yeah, me and Chai learned very
Bye.
much. Okay,
Oh,
peace.
damn, you actually have